Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 16, 2026, just 2 days ago. It introduces a rigorous new benchmark for autonomous agents, finding that a model powered by GPT-5 could only improve upon human baselines in about 7% of evaluations, despite occasionally hitting state-of-the-art performance. The paper is titled ResearchGym, Evaluating Language Model Agents on Real-World AI Research. And as we'll see later, the analysis of why these agents fail offers a really fascinating reality check on the current state of automated science. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the core framework and key results. The top diagrams contrast traditional, fragmented evaluations, like isolated brainstorming or experimentation, with ResearchGym's unified loop, where an agent iterates on an open-ended goal using a starter repository. Moving to the data in the bottom panels, Panel A shows that performance tends to plateau after about 9 hours. Panel B highlights the reliability issue, as completion rates across tasks like reinforcement learning and retrieval remain low, mostly under 30%. Finally, Panel C demonstrates that agents struggle to consistently beat the provided baselines. Table 1 positions this work within the broader landscape of AI benchmarks. The upper sections list existing frameworks that typically focus on isolated research fragments, such as just research ideation or machine learning engineering. A recurring issue in the ideation category is the reliance on subjective large language model judges, while many engineering benchmarks demand prohibitive compute resources. The bottom section, closed-loop research, is where ResearchGym really distinguishes itself. It uniquely combines a full research loop with objective performance metrics and accessibility, requiring only a single 12GB GPU, whereas alternatives often demand massive clusters. So, Figure 2 outlines the rigorous pipeline used to construct the benchmark, starting from a massive pool of nearly 1,400 award-winning papers. On the left, the process begins by using large language models to extract structured task cards, filtering for essential criteria like code feasibility and objective metrics. This automated sweep narrows the field to 90 candidates, which then undergo a manual review. In the packaging phase shown in the center, the authors carefully retain the environment and baselines, but surgically remove the paper's novel method, forcing the agent to reinvent the solution from scratch. Finally, the right side lists the resulting 5 tasks, which span diverse domains like continual learning and time series explanation. Alright, with the benchmarks established, Table 4 breaks down the results for the agent powered by GPT-5. The numbers reveal a massive gap between the agent's peak potential and its daily reliability. Under normalized performance, which scales the score against the human baseline, the average is a modest 0.4. However, the best at 3 column shows flashes of brilliance. For the TIM task, highlighted in green, the score hits 1.07, meaning the agent actually outperformed the human state-of-the-art. Yet the completed column to the right displays a mix of checks and failures, which tells us the agent often crashes before it can even finish the experiment. Well, Table 3 digs into the raw scores, placing the agent's average performance against the best of 3 runs and the human state-of-the-art. Under the TIM column, the green cells confirm that standout victory. The agent's best run hit 0.59, beating the benchmark of 0.46. But the first row, labeled RG agent, reveals the catch. The massive standard deviations, like 37 points for continual learning, show that for every success, there are multiple failures where the agent barely gets off the ground. So, following up on those inconsistent scores, Table 7 catalogs the specific behaviors that cause agents to fail during long research horizons. The authors identify 7 recurring modes, starting with overconfidence in weak hypotheses, where agents frequently skip basic sanity checks like baseline replication. Another critical issue, shown in the third row, is non-comparable experiments. Here, the agent changes multiple variables at once or alters the evaluation setup, violating the scientific method and making it impossible to track true progress. Finally, the bottom row details context length limits, which explains why performance degrades over time. Simply put, the agent's memory gets flooded with irrelevant logs, pushing out the important insights. Wrapping up, the main takeaway is the stark capability-reliability gap. While agents can occasionally hit state-of-the-art results, they currently lack the consistency and experimental discipline required for fully autonomous science. ResearchGym forces us to confront these flaws by testing the entire research loop rather than isolated fragments. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.